Hey everybody, today we're going to be making this really cool reflecting laser effect in Blender with geometry nodes. So I'm going to hop into my scene here and let's switch over to cycles, GPU compute, and lower our render samples to 128 and set our color management to high contrast. Now, before I actually jump into geometry nodes, let's go create a new collection and rename this to reflectors. Everything we want our beam to bounce off of, we're going to have to put into this collection here. So in order to give us a bit of a scene to work with while we're building the effect, I'm going to scale up the default cube, then scale it a bunch on the x-axis, drag it over, tab into edit mode, press 3 for face select, and delete this face here. And we have a bit of a hallway now that we can actually shoot our beam around in. I'll also create maybe an empty sphere, because we're going to use this to control the start position and the initial angle of firing for our beam. Now that we have this all built, I'll drag our empty out of the collection there, hop over into geometry nodes, create a new cube, and add a new geometry node modifier. Now we actually have to remember, first of all though, to put our hallway scene into the reflectors collection. Now that we're in geometry nodes, let's bring in a mesh line, an object info node, and a collection info node. I'll plug the inputs for our object info and collection info nodes into our group input so we can control them from the interface over here. Select the appropriate input, and there we go. Now let's bring in a raycast node and a vector rotate. Switch this to Euler and plug the rotation from our object info into the rotation value here. Next, let's bring in a vector and set the x to 1 and plug this into the vector input and plug this output here into the ray direction. Now we can bring in a realize instances node and plug our collection info geometry into here and plug the geometry from here into our target geometry. This realize instances node is just there so our raycast node knows to actually recognize our collection of geometry here. Now, let's bring in a set position node and plug that into our mesh line. And if we plug the hit position here into our position input, you'll see we actually get the appearance of a beam sort of firing. The other thing we'll need to do is plug the location output from our object info into the source position for our raycast. And you'll see that sort of seems to make the beam disappear. But the reason for that is that Blender is now just taking all of the points and putting them at the actual hit position. But we want to make sure that the initial point, 1 point, gets left behind here so that we actually get a connecting line between our origin and the hit position. In order to do that, let's bring in a math node and an index node. Plug the index into the value here and switch it to greater than, and plug this into the selection. Now we're only offsetting the positions of every vertex that isn't the first one, and so that gives us this nice connecting line. The next thing we have to do is we have to figure out how this would actually reflect off the surface that it's hitting. In order to do this, let's bring in a vector math node, set it to normalize, and plug our vector rotate vector into here. Shift D to duplicate, and plug the hit normal into this vector. We'll then duplicate this and switch it to dot product, and plug in our normalized vectors. Shift D to duplicate again, switch it to multiply, plug our value into the top, and set all the bottom values to 2. Shift D one more time, and multiply this with our bottom normalized vector. Shift D, switch this to subtract, and plug our top normalized vector into the top input, and the output of our multiply here into the bottom. So now the output of this subtract vector is actually giving us the reflection vector based on our incoming direction and the normal of the surface that we're hitting. So if we go ahead and bring in a raycast node, and I'll actually slide all of our nodes down here, we can go ahead and plug this into the ray direction input. Now we need to tell Blender where we actually want to fire this reflection from. And we'll want to fire it from our hit position that we get from our prior raycast. Now, in theory, this setup should work, but Blender has some issues, I think, with rounding that result in this being really glitchy if we just use the hit position as our source position directly. But if we come over here, we can actually fix it relatively easily. Create another vector math node and switch it to length. Plug this value in here, Shift D to duplicate, switch it to divide, plug our length into the bottom, and our ray direction vector into the top. Shift D and duplicate our divide node again. Plug this divide into the top and divide it by something very large. I'm going to do something like 10,000. Now if we duplicate one more time and switch this to add and plug our divide into here, we'll actually distort our hit position by just enough that Blender's sort of like rounding errors or whatever stop becoming an issue, and it looks visually exactly the same. So then we just need to, again, grab our target geometry from over here and plug that into the target geometry slot on this raycast. And we're going to bring in another set position node, plug that into here, and again, plug our hit position into the position slot, bring in a math node and an index node, switch this to greater than, plug the index into the top, and plug this into the selection. Now, we're going to actually have to iterate this process many times. So instead of just setting the threshold each time accordingly, what I'm going to do is bring in a math node and keep this at add, and then we can plug this into the threshold here. And then I'm going to highlight all of our nodes from our vector math down here to our set position and press Ctrl G. This will group everything into a tiny node group of its own, and there we go. Now that we have this, we'll hop back inside and plug the value from our add into the input node over here, and we'll press N, come down to group, and change this value here from float to integer. This way, each time we want to iterate, we just have to click one more time, and that'll allow us to create a new vector. The next issue, we haven't run into it yet, but you'll run into it very quickly, is that if we try to shoot a ray into infinity, you can see down here our raycast is limited at 100 meters. And so if it tries to shoot at something that's more than that distance away, it'll actually end up just defaulting to 000, the world origin. And so because of that, it'll just end up snapping back to the origin point, and we don't want that to happen. We just want it to not do anything if it tries to shoot into infinity. Fortunately, there's an easy solution for this. Just add a delete geometry after the set position, bring in a math node, switch this to less than, and plug the is hit value into here, and plug this into the selection. Now if we hop back out and add in a join geometry node, and join this with our first set position output, you'll see we get our ray and we get our reflection just how we want it. So we're going to have to go back inside of our node group here and export all the data we'll need for our next iteration. To do this, let's grab our hit position here, plug that into the group output, grab our hit normal, and plug that in, and grab our subtracted vector here, and plug that in, because that will be the incoming direction for our next iteration. Now that we've got those output, let's come over here and rename some of our input values. The first one is going to be my incoming vector. My second will be the normal. And the third one is going to be our position. If we hop back out and press Ctrl-Shift-D to duplicate while keeping things connected, we can plug our geometry into the geometry, position into position, normal into normal, and vector into incoming. Now if we join this with our join geometry and rotate our empty, you'll see we're getting this weird effect, and that's because we need to up our iteration actually by 1. And there we go, we have a reflecting beam. Now I'm going to speed up this next part, and I'm going to duplicate this multiple times. You can do this as many times as you like. I'm just going to do it 5 times though for this tutorial. Now that we've got this, the next part is just making this look nice and pretty. So let's bring in a mesh to curve, plug that in there, and then let's bring in a curve to mesh. Add in a curve circle to use as our profile curve. Lower that resolution to something like 8 and shrink it down on the radius. And there we go, we actually have our beam. So now we can bring in a group input, and I'm going to plug our value into the radius here so that we can control it from our interface. And I want my beam to be very small, so I'm going to bring in a math node, set to divide, and divide our input by 100. So that way we just have more fidelity and control over our actual radius. The next thing we can do is we can actually add in a trim curve node as well before our curve to mesh. And this can let us simulate sort of like a firing effect. So if you want to do something like in slow motion maybe, anything like that, you can just use these values. And then there is one more thing I want to be able to do, is that I want to be able to fire a projectile along this curve. And so the easiest way that I found to do this was by coming over here and adding in a trim curve, again, plugging that in there, and adding another curve to mesh. Bring in a circle again. And then setting this radius extremely low, something like 0.001. Grab our group input here, add in a math node, and changing the bottom value to 0.001, and plugging our value in here. Now if we plug our math node into the end slot and then directly plug our value into the start, we can add in an instance on points node and plug our mesh into the points, and in between here, add a merge by distance, set that a little higher, and then just for demonstration, I'm going to add a cube and plug that into the instance value here. Press Alt-Shift-Click, and you'll see that we actually get a cube on a whole bunch of points. The reason for this is that we actually have a whole bunch of different lines being plugged into this mesh to curve here, and we can solve this issue by just adding in a merge by distance beforehand. Now with that, we're just getting a single curve, and you can see if we slide this, we only have one point and it's being instanced along the whole curve. And if I slide this value, it just travels along the curve accordingly. I think this is really cool, honestly. I've never seen this in another tutorial, but the old way of doing it is that you would have to realize everything and then apply the geometry node modifier, come into object constraints, add a follow path, and it's a whole bunch of hassle. But here you can actually do it inside of the modifier, which I think is really cool. So now we're going to want to be able to switch between our sort of projectile versus our beam. And in order to do that, we can just add in the aptly named switch node, plug in our values here, grab a group input, and plug a value into the switch socket. Now you can see if we go 1, we get a beam, and 0, we get a projectile. And to make it so that we can control the projectile, what we're actually using as a projectile, we'll once again bring in an object info node and plug the input into our group input. And there we go. We basically have the entire beam now. So there is one last thing I want to do, is I want to make sure that in the material editor, I can make the power sort of fall off as the beam continues. So it's really bright at the start, but then it sort of fades off as it continues. The way to do this is bring in a store named attribute node and plug it in between this mesh to curve and trim curve node. Now we can bring in a spline parameter and plug the factor into the value. And for the name, I'm going to set this as beam factor. There we go. And let's jump into shading, create a new material, name this beam, and hop back into geometry nodes, come down here before the switch, and add a set material node, and change this to beam. Now I'm going to make this simpler. I'm just going to bring in an emission node and a transparent BSDF, add a mix shader, and plug the emission into the top, the transparent into the bottom, and Control-Shift-Click to plug our mix shader into the material output. Now, if we add in an attribute node and type in our name beam factor and plug this factor into the mix shader, you'll see we actually do get that sort of fall off. I'm going to increase my emission. Maybe change the color. I like something like maybe a red. Or actually, no, let's do something like a blue. There we go. Keep things positive. And we can come over to our geometry node interface, and I want to lower this beam radius as well. And remember, lowering the radius will also lower the intensity. And if you want to control this fall off a little bit more, you can add in a color ramp and set this to B-spline. Now you can see if I drag the white up, it creates sort of like a steeper, more sharp fall off. And if I drag up the black, I get much more of just like a quick dye here at the end. Personally, I kind of like the slower fall off, but you can do whatever you like. And one simple last thing, if you want this to just be a sort of heat emitting laser, bring in a black body and plug the color into the color here. And this will give you an accurate color output for whatever temperature you set here. So if you set it real high, you end up with a sort of like a whitish yellow. If you set it low, you end up with a red. And if you set it really low, you end up with a really red beam. So that's just another way to control it. And of course, we can still rotate our beam to adjust it however we like. And that is this tutorial. Thank you guys so much for watching. I hope you learned something. I hope you had a good time. If you want to get the project file for the demo scenes I showed you at the start and that are probably on the screen now, you guys can get that through the Gumroad link in the description. It's available for $1. And yeah, that is everything. I hope you guys have a great day, and thank you for watching.